how I'm delivering the notes. So write exactly where I'm writing, and so on and so forth. So I'm going to move down a little bit here. And I'm going to start in this end. We're going to talk about the real number system. We're going to start off with this idea of what are called the whole numbers. Okay, now notice where I am in the page for the box. I'm a little bit in the center, right? The whole numbers, right? You already know what the whole numbers are. When you were a kid, you started counting. You counted 1 cookie, 2 cookies, 3 cookies, 4 cookies. Then you ate all the cookies and you had how many total if you ate them all? 0 cookies, right? So the whole numbers are 0, 1, 2, 3, blah, 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 in the positive direction. Those are the whole numbers, right? Let's put a circle around the whole numbers. Then all of a sudden you got a little bit older and you got introduced to the idea of the integers. Well, the integers, we're going to put it over here, I-N-T-E-G-E-R-S, integers. And the integers are all of the whole numbers, but they also include what type of numbers? Anybody remember? Say again? The negatives, right? So if 0 is here, 1 is there, and 2 is there, and we go off in the positive direction, we also have -1, -2, -3, and we also go off in the negative direction. Those are the integers. So notice that the integers are also the whole numbers. Do you see it? Because it's inside the map, right? Then you start talking about fractions, and we call those rational numbers. Rational numbers. And the rational numbers are all of the whole numbers, all of the integers, and then all the fractions. So, such as, -1/2, -2/3, and so on and so forth. So all the rational numbers are all these together, and the circle just keeps getting bigger. Right? Well, if you put all these together in one big box here, we call this box the real numbers. And notice that the real numbers is what we're talking about up here and right here. So all of those make up the real numbers. You ever heard of Macedonia from Masebo? Yeah, same idea, right? So, let me ask you a question. The number 1, is it a whole number, yes or no? This is a level 1 question. The number 1, is it a whole number, yes or no? Yes. Is it an integer? Yes. Is it a rational number? Is it a real number? Yes. Very good. Okay. The number 0, is it a whole number? Yes. Is it an integer? Yes. Is it a rational number? Well, it's in there, right? It's in there. Okay. Everything except that, right? The denominator can't be 0, right? Right? And is it a real number? Is it an integer number? Yeah. Right? It's all part of that. Yeah. Okay, so practice with this. We're going to do an example. Okay, I'm going to give you some numbers here. Here are the numbers. Okay, the numbers are 5, 0.6, -2 2/3, and -24. All right? Let's name everything that these numbers are. Okay, the number 5, is it a whole number? Yes, so I'm going to put a whole number. Is the number 5 an integer? Yep, so I'm going to put INT for integer. And is the number a rational number? Number 5. Can you write it as a fraction? 5 divided by 1? Yes, so rational. Look at the chart, right? Look at the chart. The number 0.6, is that a whole number? No, it's not a whole number. Is it an integer? Is the number 0.6 an integer? No, it is not an integer. Is it a rational number? Yes, it is a rational number. So not whole number, not integer, but it is a rational number. The number -2 2/3. Is that a whole number? Nope, not a whole number. Is it a integer? Nope, not an integer. Not an integer. Is it a rational number? Yes. Rational number, yes. And lastly, negative 24. Is that a whole number? No, not a whole number. Is it a integer? Yes, it is an integer. And is it a rational number? Yes, it is. Hey, whoops, rational number, sorry. So you can quickly see 5 is a whole number, integer, and a rational number. 0.6 is only a rational number. Negative 2 2/3 is only a rational number. And negative 24 is an integer and a rational number. And this one is all. Okay, you guys with me so far? Yes? Good. Great. Okay, here's the second box. Okay, here are the directions. Graph -3 and -4 on the number line. We're going to graph -3 and -4 on the number line. Okay, what is the number line? A line with numbers on it? Which numbers? All the integers. Very good. So here we go. Here is the number line. Okay. Where's 0? 0 is in the middle. Very good. Where's the number -3 and -4? To the left or to the right? Yeah, so here's the number -1. Here's the number -2. Here's the number -3. And I should make a little bit more room. Whoa. Here's the number -4. So on and so forth. Here's the number 1, and here's 2, and here's 3, and that way. Okay, how do you mark where a number is on the number line? With a dot, yeah. Here is -4. Here is -3. Which is bigger? How do you know -3 is bigger? Yeah, this one is bigger because it's closer to 0, right? Isn't that interesting how we do that? But that doesn't necessarily hold true for numbers that are on a positive, right? If I ask you what's bigger, 5 or 14, you'd say 14, but 5's closer on the number line. So it only works if you're looking at numbers on the negative side, right? Or you could say the number that's farthest to the right, closer, right, is bigger. Okay, good. Looks like you got that one. Third idea here. How many boxes are there? There's 4. Which one are we on? The third. Are we almost done then? Yes, we are, right? Okay. Okay, here's the directions. Find the opposite of the number. I would definitely say opposite is a key word. Whoops, sorry. Find the opposite of the number. So the number is 2. So here's the number. Here's the opposite. All right, if I give you 2, what's the opposite of 2? -2. That's a pretty easy one, right? What about the opposite of 5? -5. What about the opposite of -7? +7, right? So opposite has to deal with sign. And when we talk about opposite, then that means we also introduce the idea of absolute value. Absolute value, one of our key words here. How many of you heard absolute value before? Raise your hands. Let the record show almost everyone's hands up. Tell me what you know about absolute value already. Yell out something, anything. Yeah. The value is say it again, you did a great job. The number's distance from 0 on the number line. Good, what were you going to say? The exact same thing, right? So, what else? It's always what? Always positive. There you go. So, if I take, here's a little bit of a rule here. The absolute value of any number A is always going to be A, right? And the absolute value of -A is going to be what? Also A, right? So there's a rule, and that's pretty important. So as an example here, right? This is the fourth box, right? No, wait. Is this the fourth one? Help me out. Yes, thanks, Dennis. Good. As a rule here, right? Or as an example, sorry. Find the absolute value of negative 2/3. What would be the absolute value then of negative 2/3? Anybody spit it out? Whatever you got. Yeah. Positive 2/3. Yes. Positive 2/3. You got it. Absolutely correct. What if I ask you this question? Here's a wrench in the game. What's the negative absolute value of negative 2/3? What's the negative absolute value? Say again? Yes. How'd you do that? Yes. Notice the negative sign's on the outside. So first, we take the absolute value of negative 2/3, which gives us a positive 2/3, but then we apply the negative sign and we get a negative answer.